Hello and welcome to this special pandemic version of the Matlab course. The Matlab course is formed of three parts. You're about to get started on part number one. I'm Adam Townsend. I have the pleasure of being your tutor for this session. Now, all of the videos are pre-recorded, so you're going to be able to go through them in your own pace. Let me tell you what the three parts are as we do this over three separate sessions. In the first part, we're going to be looking at Matlab as basically as a fancy calculator. We're going to do some call and response. We're going to look at vectors. We're going to use variables, and we're going to finish by writing a simple script. Then in the second part, in the next session, we're going to do some plotting. I think you're going to be impressed by how good plotting is. And we're going to write some functions, and we're going to do some standard some standard programming stuff, if, for, while, that sort of stuff. I'm not assuming any programming knowledge, particularly for this, although as we go through, I will occasionally mention other programming languages in case you've had the joy of programming with those. And then in the third session, we're going to do a little bit of data analysis. So I'll give you a large data file and ask you to do some analysis with that, make some plots, tell me some stuff. And then also I'm going to show you Matlab's most famous function as we do just a little bit, forgive me, I'm a mathematician, of linear algebra. So that's all coming up. The way these videos are structured, as I said, they're pre-recorded, but we're going to do each session at a time. I'm going to be available for you to chat in Microsoft Teams. So you're going to be able to chat with me on in the chat bit there. So if you have any problems, you can come and ask me questions. So we'll do each session at a time. I suggest that you do part one today, and then part two, part three, in the following days. I'm going to run through some stuff in these videos, and then I'm going to give you an opportunity to try it out yourself. I'm going to tell you when a good time to pause the video is, and I'm going to give you some exercises to play with. After that, I'm going to show you what I think the answer to the exercise is, and you can compare your answer with mine. I think this will work. I'm interested in hearing what you think, and if you're ready, let's go.
All right, let's see what we're going to be doing in this first part of this three-part Matlab course. In this first part, we're going to be mostly using Matlab as a call and response, sort of a fancy calculator. We're going to be typing some simple commands into Matlab, and we're going to see what Matlab gives back to us. We're going to be doing some basic arithmetic. We're going to look at variables. We're going to look at writing vectors, matrices, picking elements out of these vectors and matrices. The matrix is the basic building block of everything in Matlab. And we're going to finish by writing a simple script. A script is a set of commands, one after the other, that Matlab is going to execute. So it's going to do the first thing and the second thing and so on. It's all going to be in one file. So that's all coming up in today's first parts. Let's start by talking about where I think Matlab sits among other languages. Before I do that though, I should tell you that all of the material for this course is available on the GitHub repo, which you can see up here. It's github.com/pecnet/course intro to Matlab. Hopefully I will have already sent you this link anyway. And on this site, you're going to be able to see all of the stuff that we're going to be doing. If I scroll down, you're going to be able to see all the stuff that we're doing in all of the parts of the course. That's all there. And then, not that we need it today, but we're also going to be able to download for later on in the course, in the later parts, some files for some data processing, which that is going to happen in the third part of the course. So you're going to be able to follow along with here, and yeah, I think that should be good. Now, I promised to say where I think Matlab sits among other languages. If you have a problem that you think you want to write a computer program for, then one of the first questions is, am I using the right language? And this is my graph of popular to unpopular, maths to not maths. I think Matlab is pretty popular, and it's definitely rooted in maths. Some of the conventions that we're going to be seeing today really come from mathematics more than computer science, for better or worse. And it's relatively popular, particularly in academia. It's really not terribly popular at all outside of academia, mostly because it's extremely expensive. Maybe you will have played a little bit with Python, and I know the graduate school offers an introduction to Python course as well. A lot of the functionality of Matlab can now also be found in Python, and of course Python is free. But also a lot of the skills that you'll pick up are very transferable. So this is where I think Matlab is. I think it's a pretty good choice. Here's my list of pros and cons. I think there's a pretty shallow learning curve. A lot of the commands are going to be quite intuitive. I think you'll find that. And there's a lot of useful baked-in tools. Hopefully it will just work out of the box. You're not going to have to struggle too much. We're going to see that debugging and interactivity is really quite easy. I think you're going to be impressed with how easy it is to fix errors and to get into the programming language. Plus, MATLAB's been around for quite a long time. I mean, we're talking sort of 40 years or so. It was developed, I think, as a response to Fortran. I don't know whether you've had any experience playing with Fortran. It's a horrible, horrible language. But when you program in something like Fortran, and to be honest, programming in C or C++ is quite similar. You're quite far away from the mathematics, whereas MATLAB, you're a lot closer to the mathematics, particularly if you're dealing with vectors and matrices, mathematical objects like that. It's been around for a long time, which means that code from 10, 15 years ago still works. I mean, to be fair, that's not a given. But it is the case with MATLAB, which is nice. The con is, as I say here, is that it can be idiosyncratic because the commands have been around for a long time, so there's not necessarily a lot of consistency between the naming of these commands. And it is indeed extremely expensive. It doesn't tie particularly well into other programming languages, or indeed doing other things with your computer. Something like Python works really nicely if you want to maybe send some emails on the back of doing a calculation. MATLAB struggles with that a little bit. As I said, it isn't typically used outside of universities, and it doesn't always play well with other languages. But if you have a medium-sized maths problem, then MATLAB is a good plug-and-play language. I have quite a bit of experience programming with MATLAB. I write quite large simulations as part of my research in my postdoc work, and MATLAB is a good language to develop your method in. I think if you want high performance, fast computing, then I mean there are ways to do that in MATLAB. We're not going to cover them in this course, but you can use things like MEX files. But if you want high performance, then something like C++ is probably the way to go. So again, there are ways to do fast stuff in MATLAB, and you can tie things into GPUs as well in MATLAB. But broadly, for medium-sized problems, while you're developing something, it's a good way to go. I think many of you will be wanting to learn MATLAB because you will be interested in doing some data processing with it. I don't think MATLAB is necessarily the best choice for that. It's slightly, it is idiosyncratic with how it handles data, but we'll have a look at that in the third part of the course. So that's my introduction to MATLAB, and if you're ready to go, I'm going to suggest that at this point you make sure you have a cup of tea ready, because we're about to move on to the bulk of the course. We're going to start by playing around with the MATLAB desktop environment. So if you're ready, let's do it. It's the MATLAB window, and if you've opened it up for the first time, it's going to look something like this. Now you can see here I'm using MATLAB 2019A. It doesn't actually matter which version of MATLAB you use for this course. You're not going to see very much in the way of differences. Now, as I say, if you open it up for the first time, you should see this very large command window here. This is the window that in a moment we're going to start typing some commands into. If you've opened up something before in MATLAB, then maybe your window will look a little bit like this. You'll have an editor window at the top, and the command window down here at the bottom. If that's the case for you, we're just going to focus on the command window for this section of the course. So you can go ahead and get rid of anything up here in the editor. So we're going to treat Matlab at first like a fancy calculator. So let's go ahead and type in our first Matlab commands. So how this is going to work is that I'm going to show you some stuff, and then I'm going to give you some time to pause. I'll set you a little exercise, and that will give you an opportunity to try the stuff that I've just showed you, and then see if you can answer the exercise. That's the plan. So let's do our very first calculation with Matlab, and it's going to be 3 plus 4. You see, I thought you would be impressed, and here we go. I'm going to press enter. Aha, and we have 7. Good news. All right. Now, if you liked addition, you'll also like multiplication. So here's 3 times 4. Again, star here for multiplication. Press enter. What about 3 divided by 4? With the slash. Now, if you've used other programming languages, particularly Python 2 or maybe something slightly more advanced, you will realize that this isn't obvious that this is going to give you 3/4 or 0.75. Some programming languages have it that an integer divided by another integer always gives you an integer. It normally rounds down, but not for Matlab. So Matlab behaves in the most mathsy way, I suppose, that it can, and so it gives you 3 divided by 4 is a float, is a decimal, 0.75. What about exponentiation? 3 to the power of 4 using the hat. There we go. Is 81. Well done if you work that one out in your head. Now, every now and then on Facebook, these memes that come around that have like a bunch of numbers, they say it's only for genius, and it's a bunch of numbers added or multiplied together, and at the end they multiply by 0, and then add 1 or something. You're supposed to be a genius if you remember the order of operations, sometimes known as BIDMAS or PEMDAS, depending on where you first learned this. Is Matlab able to does it know the order of operations? Let's see, 3 plus 4 times 5, so it should do the multiplication first. And here is our first little challenge. So I'm going to pause now to give you an opportunity to look. You can, of course, flick to the GitHub page, which has the everything I've put in so far, and then the exercise which is here. So pause now and have a go. All right, so let's see whether Matlab was able to do that. 3 plus 4 times 5. 4 times 5 is 20, and 3 is 23. Hooray, good stuff. All right. I mean, I think you would be disappointed if it didn't work. Let's move on to using variables. So section 4. Let's set x. X is a good name for a variable, right? Let's let x equal 2. There it is, x equals 2, we just type it in, press enter, x equals 2. Now you should be able to see, now it might be down here on the left hand side, for some of you it might be on the right hand side in a pane, that's okay as well. But you should somewhere be able to see a pane. Don't worry if you can't see this, it's not too much of a problem. You should be able to see the workspace, which has here x and the value 2. In fact, all of the variables that you define within a Matlab session are listed down here in the workspace, so you can come down here at any time and see what the values of all your variables are. Of course, you can also ask for it in the command window. So let's ask for x, and press enter. There it is, x equals 2. If we want to replace x with something else, x equals -9. I'll move the mouse. Well, now x is replaced, and you can see in the workspace x is now -9. In mathematics, we typically like to have short variable names, normally 1 letter. In programming, this is generally a bad idea. You can't use different sorts of letters, like underlines and bolds and that sort of stuff. So in programming, it's typically a good idea to give a nice long name to your variables. So if we're interested in a square, for example, maybe we want to say that the width of the square is equal to 3. The moral here is that long names are good. Width is 3. Because this means that you can say area equals now width squared, and when you come back and look at this, Not that we're going to do here, but later we're going to move on to writing whole scripts. When you come back and look at these codes, these lines of commands, then you want to understand what it's doing. Why are you squaring width? So long, names are good, area equals 9. Let's have a go at doing something a little bit more complicated. Let's let y equals 12 divided by 2 plus 5. So, we can do the arithmetic and then set it equal to y. 12 divided by 2 is 6 plus 5 is 11, so that's why y is 11. We can do y plus 1 squared using brackets. So it's quite intuitive, I think. Y plus 1 is 12. 12 squared is 144. That's gross. And now let's go and use some built-in Matlab functions. Matlab knows a lot of standard maths functions. Let's let y equals sine of x times by cos of x. Okay, so x is minus 9. We've already specified that. And sine and cos will do this in radians. So we're not expecting to know what the answer is here. I don't expect to know what sine of minus 9 is in radians. But just to show you, 0.3755. So I'm going to pause here, and I'm going to let you type in the commands that we've just seen, so you can convince yourself that they work. Here they are. So have a go at typing these in. Pause now. Next, we want to have a look at how easy it is to get help. I think one of the best things about Matlab is that it's very easy to get help. The built-in help is very good, and their online help is also very good. Matlab has been around for a long time, and so pretty much if you have a question, you're going to be able to find the answer on the internet. I want to encourage you to use Google as much as possible when you have problems with Matlab. So let's say we want to find the square root of x, but we don't know what the function is. Well, I'm just going to encourage you to use Google. That's all there is. So let's open up Google. I'm going to search for Matlab square root. And here it is, squirt. Okay, maybe no surprises here, but that's the function. So let's go ahead and try it. Square root of x. Now, if you've been following along, x should be minus 9 by this point. Of course, x could also be whatever you have, whatever you've let it be. But if you've been following along, then x is minus 9. What is the square root of minus 9? Right, it's got to be complex. Can Matlab handle complex numbers? Let's see. Yes, it can. So the square root of minus 9 is 3i. I is the imaginary number. Matlab can handle imaginary numbers. 0 plus 3i. There it is. Now suppose we want to know more about the square root function. A really good feature of Matlab is that you can find the help for any function at any time simply by typing in the function as we've done here. So you can click on this, or we can type it out again, square it, and then by pressing F1 on your keyboard. So if you press F1, you should see the help pop up, and here it is. If you're on a Mac or some other sort of laptop, you might have to press the function key to allow you access to F1, otherwise you're going to end up changing the brightness, turning the brightness down no less. You don't want to do that. There's so much more exciting stuff to come. Here's the help that comes up. Here is b equals square root of x, returns the square root of x, of each element of the array x. So it tells you everything you could possibly want to know, good grief, about the square root of x, how it works on vectors and matrices, all this sort of stuff that we're going to look at later. That's all there. Okay, so now using Google, I have a challenge for you. I'm going to ask you to try and find 3 things. I'm going to bring them up on the screen. I'm going to give you a moment just to type in square root of x, but I'm going to ask you to try these 3 things down here. I want you to find the inverse sine of 1, so that's the inverse of the sine function. I want you to find the remainder when 14 is divided by 3, and I want you to find the absolute value, or the modulus, of minus 4. All right. So have a go at Googling to find out the commands for this. pause it now, and then we'll come back and I'll show you how I did it. All right, let's go ahead and see how I managed to look at these three things here. The first thing was to find inverse sine of 1, and hopefully if you Google that, you will have found that the function you need is a sine. So it's arcsine a sine of 1. That was the question, and hopefully you might be able to work this out in your head as to what this number is. It should look familiar to you. This is in radians, right? So you want what angle gives you 1 in a sine graph, which I think should be, let's see, pi over 2. So let's have a look. Do we get pi divided by 2? We do. 1.5708. If you multiply that, you get 3.1416, which is a decent approximation to pi. Let's have a look what the next thing was to find the remainder when 14 is divided by 3. So there's a couple of options here. You could have tried rem, 14, 3, being careful here to use the comma. So pay close attention to the syntax. Sometimes, or you might be tempted to put a divided by sign here, but it's not. It's a function that takes 2 arguments. 14 divided by 3 gives you the remainder when 14 is divided by 3. Let's check it out. 2, good. You might also have found mod. And for positive numbers, mod and rem give you the same thing. If you fancy a bit of a challenge, why not try with a negative number and see if you can figure out the difference between mod and rem. All right, so we're now going to move on to understanding what the semicolon does in MATLAB. So here's my question for you. This is section 6. What's the difference between typing in x equals 40 and x equals 40 followed by a semicolon? So have a go at that now. See if you can articulate the difference, and then unpause when you are happy. Time to pause. So I asked you what the difference is between x equals 40 and x equals 40 with a semicolon. Let's check it out. X equals 40. If we type it in, okay, sets x to be 40. We can see it over here in the workspace. And it also gives us x equals 40. It prints it back out of this. Let's try x equals 40 with a semicolon. Okay. So this does set x to be 40. In fact, if I let x be something else, let's try it with 30 in a semicolon, you'll be able to see in the workspace that the 40 changes. There you go, you see x is now 30. But it doesn't print x back out of this. And when we write large scripts, that's going to be good for us because we don't want Matlab printing stuff out all the time every time we give it a command. Let it do the work, but we don't need to see it's working. At the end, we can probably trust it. All right, so we're about to move on to section 7, which is talking about vectors and matrices. So things are about to get a little bit more interesting. So if you fancy just a short break, now is a good time for that. All right, time to move on and think about vectors and matrices. Now the building block of MATLAB is the matrix. Everything is a matrix. So this can represent lists or data tables. Many of you will be interested in MATLAB for its data processing capabilities. Or, of course, matrices can represent, actual matrices as mathematical objects for solving linear systems and that sort of thing. So now we're going to go ahead and build our first matrix. And it's not going to be even a full matrix. It's just going to be a vector. It's going to be one row. Here it is. So we're going to let x be the vector that has 29, then 43, spaces between the elements, 13, 3.2, and finally minus 26. All right, no semicolon because we want to see what x is doing when we press enter. All right, and there it is. X is 29, 43, 13, 3.2 minus 26. In case you're curious, you see all of these as floats because that is as decimals, because 3.2 is a float. And if you had all integers, it would just output them as integers. But you can see that it's also down here on the left-hand side with x. Now, how about a matrix? Let's let y equal. We're going to be 1, 2 on the top, 3, 4. So a 2 by 2 matrix. So we're going to have 1, 2 at the top, 3, 4 at the bottom. So we use the semicolon to separate rows in Matlab. That's the notation. Let's go ahead and press enter. Okay, so 1, 2, 3, 4, that's the order, that's how it's going to be. Now there are some special characters that we can use in MATLAB as well. So here the semicolon gave us a new line. Let's have a look at what the colon does. I want you to have a look at what 1 to 10 does using the colon in the middle. So square brackets either side and 1 to 10 in the middle. Sorry, with the colon in the middle. Let's press enter and see what it does. All right, so it gives us a vector that goes from 1 to 10, including the endpoints. Note that, so that's different to many languages. It includes the endpoints, so 1 to 10 is 10 elements long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going up in ones. If you want to go from 1 to 10 going up in twos, say, then we can put 2 in the middle with the colons, and let's see what that does. All right, so okay, so that goes from 1 to 10 up in 2. So it goes 1, 3, 5, 7, 9. And then, of course, it can't do any more because the next one would be 11, which is more than 10. So you don't have to worry about the endpoint, the 10 here, necessarily being included. It's not important. We don't have to go up. We can certainly go down. Let's go from 3 down to 2, but in steps of minus 0.1. Right? So we're going to go down. So we have to set the step as negative. 3 going down to 2, steps of minus 0.1. Let's give that a go. All right, so here it is, 3, 2.9, 2.8, 2.7, all the way down to 2. Don't be thrown by this new formatting. If the vector is too wide, then Matlab uses this formatting where it tells you the columns 1 through 9 is here and columns 10 through 11 are here. All right, so now I have some questions for you. So I'm going to show the questions and I'm going to give you a bit of time to once again type in what we've just done in this section and have a little bit of a play around. So here are my questions for you. What do apostrophes do? So I want you to try, once you've let x and y be something, I want you to see what x apostrophe and y apostrophe do. And then I want you to see what's the difference. Here we had x going 29, 43 and so on with spaces in between. What if you put commas in between instead? Is there a difference? And finally, before typing it in, I want you to have a think about how long this vector is here. So how long is this vector? How many elements are in this vector? All right, so have a think. And then once you've decided what you think the answer is, then type it in and see whether you are right. So now is a good time to check that out. So I'm going to give you an opportunity to pause here. All right, let's see what these things do. Let's have a look what x dash or x apostrophe and y apostrophe do. That's the first question. So let's type in x apostrophe. So in fact, before we begin, let's type in x so you can see what x was. All right, x apostrophe goes down. What about y? All right, so that goes from 1, 2, 3, 4 to 1, 3, 2, 4. So the apostrophe, it looks like it transposes the matrix. Right? That's what it looks like it does. In fact, a little bit later when we play a little bit more with complex numbers, you'll see that it does what I think is the Hermitian transpose or the complex conjugate transpose. But for real numbers, it just gives you the transpose. So rows become columns, columns become rows. What else did I ask you? I asked you, what do commas do? What if we type in x with commas instead? All right, let's try to do that. So x equals 29, 43, 13, 2, minus 26. And x, you can see it over here. And if you compare with x we had it before, it is exactly the same. It is completely up to you whether you want to add the commas in or not. Remember, semicolons are for different rows. It's up to you whether you put the commas in or not. And then what was the final question? Final question, oh, how long is this? 1 to 10 in steps of 0.5. So this is asking you to remember that this includes the endpoint. So this should be 1, 1.5, 2, 2.5, and so on, all the way up to 10. So if you calculate it, how long that is, let's have a look. So it's 1 going from steps of 0.5 up to 10. Maybe 19, let's see. Aha, indeed it is 19. There we go, going up in steps of a half and including the endpoints 1 and 10. There you go. All right, so we're about to go ahead and manipulate some matrices now as we move on to section 8. So the first thing I want you to do is to, in this section where we're going to start manipulating matrices, so the goal of this section is to select elements from matrices. So far we've been able to put in matrices in there, that's all fine, but what if we want to edit individual elements? We want to select individual elements. All of these are good options, so we should find out the best way to do that. Let's start. Let's let x be another row vector. This time we're going to use some numbers that are a bit more familiar to us. So let's use 314159. There we have our row vector of integers. Let's see what happens if we want the second element. Now the second element here is going to be 1. Matlab starts counting at 1, and you can argue about the sensibleness of this, and if you're like me and think this is a shame, then you're in good company. But Matlab starts counting at 1, so this is the first element, the second element, the third, fourth, fifth, and sixth. So it's like Fortran in that regard, but it's not like Python, which starts counting at 0. Let's go ahead and ask for the second element. That's x. And then round brackets, so sort of normal brackets, 2 to select the second element. There it is. Answer is 1. What if we want to change? Maybe we want to change the value of the fourth element here. So currently it's 1. Let's let it be 50. So let's let x4 equal 50. And that's it. Easy, just with the round brackets, you see we have been able to put 50 in there. Let's go ahead and create a matrix. So this time we're going to have more dimensions to play with. Let's have 3 and 10 on the top row. And we can have -1 and 6 on the bottom row. There's y. Let's say we want to change the top right element over here. So currently it's a 10. I want you to think about how we might go about changing this top right element here. In the vector, we just gave it its position in the row. This time, because it's a matrix, we have to give it its coordinates. And so if we want to change the 10, that's here. So that's the first row and the second column. So it's rows and then columns. So that's the normal mathematical way of listing coordinates for matrices. It's the opposite of Excel, you might have noticed. Let's go ahead and try to do it. So let's specify 1, 2 in round brackets. So that's 10 here. Let's go ahead and let's set this equal to 100. All right. So here we have yes. Y. Let's go ahead and set it equal to 100. Let's press enter. And there's y. Now we have 1, 2, we have the 100 exactly where we wanted it to be. Now we're going to go ahead and do some larger matrix multiplication. So if you want to just pause the video at this point, you can have a play around with what we've done so far, and then we can go and start playing with larger matrices. here's what we've done so far. We've gone up to here. All right, so now we're going to go ahead and create a larger matrix to do some matrix manipulation with. This is what I want you to type in. I'm going to explain what this is to you later, so don't worry right now that it's not going to be obvious what it is. I want you to type 1 to 10 with the colon, apostrophe, multiplied by 1 to 10, like this. So you're going to type in that, and then you should press enter, and you're going to see, ta-da, a multiplication grid. We have 1 to 10 multiplied by 1 to 10 in a table like this. So you should be able to see that the coordinates correspond to the product pairs, so just like a multiplication table. Let's say we want to pick out what's on the 4th row and in the 1st and 2nd column. So we want to pick out these two elements here. That's easy enough to do. We ask for A and then round brackets. So we're gonna, we're gonna put in the 4th row and then the 1st and 2nd column. So square brackets, because we're putting in a vector of coordinates. So you see, that's the 4th row and then the 1st and 2nd columns. Let's see what it does. Hopefully it should print out 4, 8. It does, nice. Now let's see what happens if we try and go for the 8th and 9th row and the 8th and 9th column. Can we get this square here? 64, 72, 72, 81. Let's try. So I'm going to ask for the 8th and 9th row, the 8th and 9th column. Again, asking for vectors of rows and columns every time here. It works. 64, 72, 72, 81. Now, what if we want to go ahead and ask for the 3rd row, maybe going from the 4th column all the way to the end of the matrix? Now, you could specify that you want from 4 all the way up until 10, but there's an easier way to go to the end of a matrix, which is to use the end command, which is built into Matlab. So let's say we want the 3rd row, and I want columns 4, 2, so again using the colon, to the end. 4 colon n takes us all the way to the end. Let's just see that it works. So hopefully we're going to go from 3, from the 4th column all the way to the end. Let's give that a try. There it is. 12, 15, 18, 21, 24, 27, and 30. What if we want the, this time, maybe we want a whole column. So we want the 4th column, but I want to go from the 1st row all the way to the last row. Easy enough. Or we could say, all right, so I want row 1 to end, that's all of them, and I want the 4th column. Let's try. 4, 8, 12, 16, and so on. All right. But 1 to end is a little bit lengthy, so there's a shorter version of that syntax, and that looks like this. It's not 1 to end, it is just the colon by itself. Colon by itself means 1 to end. All right. So that colon 1 to end, so that's all of the rows and the 4th column. That should give us the same thing. There it is right there. And we can take these sorts of expressions and throw them into other functions. Say we want to go ahead and sum the columns up. We can go ahead and do that. So let's sum up this column. So we're going to sum all of the rows and the 4th column. So I'm just taking a colon comma 4 and I'm plonking it right here into the sum function. It's just going right into there like that. So hopefully that should add that up. You might like to play mental arithmetic at this point. The sum is 220. There you go. All right, so I'm now going to give you some exercises to have a go at. I'm going to show you what we've done, so you can type them into your machine and see that they work. And then I'm going to give you you can pause the video and you'll have some time to play around with these exercises. Here they are. So I want you to try these things down here. I want you to create the matrix A, which is going to be magic 5. I'll explain that later, but maybe you can already figure out what type of matrix this is. And I'm going to ask you to pick out these following elements down here, and I'm going to ask you, what does this instruction here do? All right, so that's some things to try. If you fancy a harder challenge, then you're welcome at this point to continue down and have a play at some of these. Now, I don't particularly expect you, depends how much time you have at this point, but I think you should at least try the first two down here. If you're able to achieve the first two things, then that's pretty pretty good going. These three things down here are just for the super keen. So I'm going to show you how to do the top two things here, and I'm going to show you how to do all of these things. So you can pause the video now and have a go. Alright, so I promised we'd have a go at some of these, so let's go and try that now. So we're first going to create this matrix. So it's magic 5. There it is. Nice looking matrix. And let's see, we're going to get the element in the first row, first column. That was the first thing we asked for. So that's A11. There it is, 17. Good. Then I wanted the fifth row, second column. All right, so that's A52. 18, there it is, fifth row, second column. There's the 18. Then I wanted all the elements in the last row. Okay, so that's the last row. So I could have asked for row 5, and some of you will have done that, that's fine. Or you could ask for end, meaning the last row, and you want all of the columns. So that's colon. There it is, you see. So you have 11 over to 9. Nice. And then I asked you to try getting the element in the sixth row, fourth column. And if you tried that, you will of course realize it doesn't work because there is no sixth row. But I wanted you to try. If there was sixth row, fourth column, I wanted you to try because this error message is quite common, I find, at least in my experience of using Matlab. And here's the error message: index in position 1 exceeds array bounds. So that just means that the index in position 1, right, that's 6, is well, it's larger than the size of the array, that's A, the matrix. Must not exceed 5, that's the size of the matrix. In my experience, this is a pretty common sort of error. It's quite, it happens quite often that you accidentally try to access some part of the matrix that doesn't exist through some error in indexing. So I just wanted you to see what that looks like. And then finally, I asked you, what does this do here? A2111, 4. So if we try that, so that was rows 2, 1, 1, 1 again, and 4. What do we get? Well, so we get row 2, column 4. Right, that's row 2, column 4, 14. There it is. And then we get row 1, column 4, row 1, column 4, row 1, column 4. So it's the same thing. Let's just check it's there. Row 1, column 4, there's the 8. So I just wanted to show you that as well. So you can ask for the same thing again multiple times if that's something you're interested in. And then the questions that continue afterwards, I said, show that the sum of the first column of A equals the sum of the last column of A. All right, so let's take a look at the first column of A. So that's going to be all of the rows and the first column. And I want the sum of that. So, oh, I haven't shown you this, and I've used it. Let me tell you. So down here at the command window, if you press the up key on your keyboard, it shows you your previous commands. Nice, right? And the little red line on this one tells you it didn't work. So you can scroll up and down and find things that you used most. It also tells you here your favourite commands. I mean, I'm not really sure these are my favourite commands, although I assume I've used these at some point in my research. Nice. All right, so we wanted this, the first column, and I wanted you to sum them up. So we just put this all inside a sum. So let's do that. The sum is 65, all right. And I wanted to show that the sum of the first column of A is the sum of the last column of A. So the last column of A is not 1 this time, but again I could ask for 5, or I could ask for just end. And you also find that you get 65. Now, okay, interesting. I then asked in the second bullet point, and I'm not going to show you these harder ones here, but I asked you to find the sum of the diagonal of A. And I gave you a hint. Search for the function that gives the diagonal of A, or you can guess what the function is. So let's have a look. So if you had a guess, or you did a bit of a Google to find the function that gives you the diagonal of A, maybe you would have found diag. Diag of A gives you the elements that are on the diagonal of your matrix. So here was our matrix. Where's A? There it is. And on the diagonal, we've got 17, 5, 13, 21, and 9. 17, 5, 13, 21, and 9. And then if I wanted to add that up, I could do sum diag A, and we get 65. Now, some of you linear algebra fans will know that there's a function that is exactly this, the sum of the terms on the diagonal, which is known as the trace of a matrix. And so if we ask for a trace of A, it also gives you 65, but you didn't need to know that. So again, we get the same number, 65, and that's because this matrix A, which I made with magic 5, is indeed a magic square. And if you are not familiar with magic squares, this is what a magic square is. It's a matrix where the sum of all the rows and all the columns, and indeed the diagonals, give the same number. They're quite a fun thing in recreational mathematics, and maybe you saw them in primary school. But I mean, they go quite a long way back. You can have a look at these ones from. This is on Wikipedia, obviously. Here's something from China. Some nice thing from an Indian manuscript, and there's quite a famous one actually on the Sagrada Familia in Barcelona. If you ever get to go, I mean, I'm sure the church is nice, but really it's all about the magic square. So I suggest you go and enjoy that. All right, back to what we were doing. Yes, because we're about to move on to the next section, which is doing arithmetic with vectors. So let's go ahead and try to do some arithmetic with vectors. This means we're going to take a vector and we're going to add something to it, or we're going to try multiplying vectors together. Let's give it a go. Let's create a vector 1 to 10, like this. All right. Let's create another vector y, which is going to be 11 to 20. So these are the same size. And now we're going to be able to add them together, right? Let's do x plus y. Right, that's not too surprising. X minus y. All right, so far it's doing what we call element-wise operations. Right, that means that you get, with x plus y and x minus y, you get something which is the same size as x and y, and it's done it element-wise, that is element by element. So the first element plus the first element gives you the first element, if that makes sense. Let's do maybe 2 times x. Yep, there we go, a lot of even numbers. Even if you do x divided by 2. Alright, so that's a half, 1, 1.5, 2, 2.5, and so on. So far, so good. And then, what about x times y? So at this point, I want you to have a go at typing in what I've done so far. And I want you to go and type in x times y and see what happens. All right, so this is on section 9, so I want you to get down to here type in x times y and see what happens. So I'm going to pause now. So if you try x times y then, you get an error. And I wanted you to see this because this is well, you might find that this becomes a common error. And it says that incorrect dimensions for matrix multiplication. All right, so you might have to cast your mind back to when you first learnt about matrices in linear algebra. Check that the number of columns in the first matrix matches the number of rows in the second matrix. So that's what's going on here, is that Matlab is assuming that if you're multiplying two vectors or indeed two matrices together, then what you want to be doing, or rather it thinks that what you want to do is matrix multiplication. You might remember there are funny rules for multiplying matrices together, and one of these rules is about the sizes of these two matrices. But if you want to perform element-wise multiplication, which of course we do, then we can't use star, we have to use dot star. So this is a common mistake in Matlab, and I wanted to bring it up right now. So in the last session, I'm going to be giving you a large data set to be doing some data processing with, and I bet at some point you will try to multiply two things together, or maybe divide two things together. We'll have a go at that in a second, and you'll forget to use the dot. But I warned you here first, so let you be warned. Here we go. So if we want to do element-wise multiplication, we have to use dot star. There you go. So now you've got 1 times 11, 2 times 12, 3 times 13, 4 times 14, and so on, all the way up to 10 times 20, which is 200 over here. And the same is true for division as well. Dot slash. There we go. 1 divided by 11, 2 divided by 12, and so on. You also have to use the dot for exponentiation if you want to do element-wise element-wise squaring rather. Let's have a look. There's a bunch of square numbers. Or if we want to do 2 to the power of all of our numbers, again dot hat. There you go. There's our powers of 2 up to 1024. All right. So let's our first look at vector arithmetic. I have some things for you to try. So type in these things here, which we've just done, and then have a go at these things down here. All right, so we're going to pause now. So hopefully you've tried these down here. Let's have a look at how we might do those. So my first question for you is to sum the numbers from 1 to 100. So that's I think that's quite easy. 1 to 100 is a vector of all of the numbers 1 to 100, and if we sum them, 50-50, there it is. You might remember that there's a formula for adding up integers 1, 2, 3, 4 up to a certain number. There's a story attributed, or rather the story says that it was Gauss, the mathematician, who came up with this formula when he had a substitute teacher one day when he was in primary school, and the teacher thought that it would be a good time-wasting exercise to get the students to get out their blackboards, or their little slates rather, and start adding up the numbers 1 to 100. And he thought that might take a while, and Gauss manages to do it in less than a minute. To the teacher's amazement, that's because he'd realised that there's a formula. He'd worked out the formula for working out this. So that was my question there. The second thing I asked was, can you sum the squares from 1 to 5? All right, so the squares from 1 to 5 are 1 to 5 squared. All right, so that's 1 to 5 squared, element-wise operation. And I want you to sum those. So again, pressing up to show what we're doing. Sum of these 55. And then the final question was, what is the mean of the powers of 2 from the 0th power, that's 2 to the 0, up to the 6th power, that's 2 to the 6? and I invited you to Google the function to find the mean. Right, well, let's work out the powers first. So from the powers of 2 from the 0th power, so up to the 6th. So we'll do 0 up to 6, and then I want 2 to the power, and element-wise to the power, hence the dot. So let's just see that that gives us what we want. There we go, it's 2 to the 0, 2 to the 1, 2 to the 2, and so on, up to 2 to the 6. And I wanted you to find the mean of these. So we could go up and ask for the mean. You might have guessed that the function is called mean. There it is, and the mean is just over 18. Alright, so we're now going to move on to the last part of today's section, which is writing a simple script. So that should be quite exciting. Alright, so let's go ahead and now move from playing around in the command window as the final thing that we do today, to writing a simple script. So this is section 10 in the GitHub here, writing simple scripts. So a script is the simplest type of Matlab program. So far we've been putting everything inside the command window, which is here. Let's create a new script. So with a script, so if you go up to the top left, you should see a new script button. If you don't see a new script button, you have to go to the Home tab. So maybe you're on the Plots tab or the Apps tab. You want to go to the Home tab and then New Script. When you do so, the window should look like this. So now you have an editor window here with a blank script, and the command window has become smaller, shrunk to the bottom. So with a script, we can have a load of commands next to each other, and then we can run them all at one time. The first thing, however, we are going to save this script. So let's go ahead and save this script, and we can do that by go ahead and clicking save. And I'm going to save it as magic square test. Right, so we're going to play around with some magic squares again. Magic square test. Now it's important that we don't use spaces in the name of Matlab files. If you use a space, it won't work. It won't be able to run it. So underscores are your friend. That's good. Dashes, okay. Underscores are the best way to go if you want to do that. Magic square test. And once you've saved it, you can see the name is here, and you might even be able to see down here on the left-hand side. Okay, so here is the aim of the script. As it says on the Matlab, we're going to see if switching the top and bottom row of a magic square keeps it a magic square. So remember, a magic square has all of the rows and all of the columns and indeed the diagonals adding up to the same number. Let's see whether this is true. So we're going to start by letting the matrix have size 4. Now I'm going to type all this in, but you will be able to, in fact, copy and paste this from the GitHub. You'll just be able to copy and paste this in, but I'm going to type it in, explaining what I'm doing it as I go. If you'll excuse me. So this is going to be the size of the matrix. We can leave comments in Matlab by using the % sign. Anything we type after the % sign isn't read by Matlab and is just a note to us. In the Matlab editor, it is green by default. So that's the matrix size. We're going to let M be a magic square, size 4 by 4, right? That was what the n is for. Remember, we're using the semicolons here because we don't want Matlab to spit out the output of these lines every time. So I'm going to take the top row, which is the first row and all of the columns, and I'm going to pick up the bottom row, which is the last row and all of the columns, and then I'm going to set the top row, right, that's M1 colon, to be equal to what I've just saved into the variable bottom row, and I'm going to set the bottom row of the matrix to be equal to what I've just put into the variable called top row here. Now, once I've done that, I'm going to print out the sum of each of the columns of the matrix. There's an easy way to do that. It's just by asking for sum m. Now, if you want MATLAB to print something out to you, you have two options. Either you can just type in the command without a semicolon. That's completely fine. That will just work. Or you can use the disp function. Anything that's disp for display. Anything you put inside the disp function is displayed out to you. So we can write a little note to ourselves here. So to display, we can use the function disp, or we can just leave off the semicolon. I also want to display the sum of the diagonals, so that's what we just found. In fact, these little tooltip boxes are quite nice, right? As you're typing the names of functions, these options come up that remind you how the function works. If you want, you can click More Help, and it takes you to the help file for that particular function, in this case, diag. There it is. It took a while to load, but there it is. So I want the sum of the diagonal. And then I told you that there's a... oh no, I didn't tell you this. Okay, I'm going to tell you this now. There's a formula that tells you what this number always is for a magic square of a particular size. So long as you're using all the numbers, 1 up to the size of the matrix squared, then there's a formula for what this magic constant is. And that formula is n times n squared plus 1 divided by 2. So I want it to print that out, so I'm going to ask it to disp that. That's the so-called magic constant. All right, so that's our script. We can go ahead and save it. It's up here, the save button. Now suppose I want to go ahead and run this script. Well, we can just go ahead and click run up here. So I'm not going to do that just yet, because I'm going to allow you the time now to go over to the GitHub page, copy and paste all of this, and go ahead and click run and see that it works. Once you're happy, come back to the video and we'll continue. So hopefully this works for you. Let's go ahead and click run. All right, so 3 things printed out. Firstly, sum m. So if you have a matrix and you give it to sum, it shows you the sums of all of the columns. So that's the sum of the first column, the second column, the third column, and the fourth column. And then I also wanted what's the sum of the diagonal. That's this. And then I also wanted this magic constant, 34. So we can see we have 34s everywhere. This is still a magic square, even once we've done this transposition here. Now, there's something that's particularly nice about Matlab, which is the use of breakpoints. And if you want to go ahead and run some code, that's fine. But sometimes maybe your code doesn't work, or maybe you get an answer you're not expecting, or really you just want to have a sense of what's going on while your code is running. You can use breakpoints to pause the execution of your script at some point. So let's say we want to put a breakpoint in here. So it's going to stop before it executes line 5, and it's going to allow us to poke around and see what's going on. So we can go ahead, click somewhere on line 5, and we can add a breakpoint. So up here you go to breakpoints, and we're going to go ahead and set a breakpoint. So if you press set/clear, we're going to set a breakpoint, and the red circle comes up. That's telling us that the breakpoint is there. There's a keyboard shortcut for breakpoints, which is F12. Again, if you're on a Mac, you'll have to hold down the FN key. But F12, if you mash it a bit, you'll see that it toggles the breakpoints. So now let's see what happens when we press run. And again, there's a keyboard shortcut for that. So you could go ahead and press run, or you can press F5. That runs the code. So it started running the code. I pressed F5, and it's got down to here. Now we've got the green arrow pointing, and you see there's a K down here, K for keyboard, because it's waiting for you to type something in if you want. It means at this point we can ask, what is M? We can type it in. M, press enter. There's M. That's what it looks like at the moment. In fact, we can do more than that. We can hover over bottom row. What is bottom row? Well, you hover over it, this tooltip comes up. What's top row? Now hover over it, up comes the tooltip. That's good, right? I think that's really nice. So this allows us to see what's going on during the code. No Matlab course is complete without you seeing breakpoints. If you want to keep on going, the run button has just become continue. That's fine. You can go ahead and press continue, or you can press F5 again. This time I'm going to just push the button up here. It's going to run to the end of the file and stop. There we go. Run to the end of the file. Here we have all the 34s as before. So I'm going to give you some time now to have a play adding in these breakpoints yourself, see that it works, and then I'm going to tell you what we're going to do in part 2 of this course. Fabulous. So hopefully you had a play with this and you were happy with the first script that you've written. Let me tell you what we're going to do in the second part of this course in tomorrow's session. So here is part 2, and we're going to look at plotting. You're going to be very impressed how easy it is to plot things in Matlab, and we're going to graduate from writing simple scripts to writing functions. So this time we're going to write whole functions that are going to take in inputs, and they're going to give us some outputs. Okay, that's a function. But we're going to write those and we're going to call them. We'll see what that's like. In particular, we'll have a play with a collapse conjecture. So if you like, you can look that up on Wikipedia before the next session. And we're going to look at doing ifs, fors, and for and while loops. So this is a standard computer programming, but I have to show you what they look like in Matlab. So that's all coming up in the next part of this course. And I hope that you will join me then. Well done so far on today's session, and I will see you in the next part.